If you remember in the middle school, right, you were assigned problems like these ones. So you have, for instance, this square or this rectangle, right? Yeah. Obviously, the area of this rectangle, yeah, is length times width, right? L, W. So this area is easy to compute. But in the middle school, you were challenged to compute more complex shapes. For instance, if you subtract a right triangle, for instance, this one, right? So this is L. So this is X and Y, right? So suppose this is a right triangle, so you cut this section from your rectangle. So the way to get this one is, okay, we can get area equals L times W, and then the area of the rectangle is, of the triangle is X times Y divided by 2. So the way to find the area of the region after you cut this one was L times W minus X, Y over 2. So this was the way you were finding the area of this complex shape. So you take the area of the rectangle and then you subtract the area of the triangle. That's the cut. So pretty much we are going to do the same here for calculus. In calculus, yeah, let's suppose here we have two functions, right? Yeah, we have a function f and we have a function g. And then we define the interval a, b. So it's an interval in the domain of the two functions, right? And, well, in this situation, if you want the area of the region between the two curves, this is, well, you know the area under f, area under f was the integral from a through b fx dx. So this is the area under f. The area under g of x is the integral from a through b fx gx dx, right? And the area between the curves, so a, so this a right here, is going to be exactly as you did here. So you have a big area, you have a small area, you want the area after you subtract this small from the big one, is the difference of the two areas, so it's pretty much the same here. You are going to have the integral from a to b, yeah, of f of x dx minus the integral from a to b g of x dx, or is the same if you use properties of the integrals, the integral from a to b of f of x minus g of x dx. So where you have to subtract the upper function minus the lower function. So the upper minus the lower, correct? So that's the idea. This difference, if you subtract the upper minus the lower, is positive, is what you want. If you subtract the lower minus the positive, this area is going to be negative. The number is going to be correct, but the sign is not going to be correct. Remember that areas are always positive. The only situation is when the area is below the axis, but in this case, right, has to be above the axis. Okay, so you see, it's the same reasoning as you did in middle school, right? So you only have to identify the upper function, the lower function, subtract them, and then integrate between the interval you want the area. So the area is delimited by this line at the left, this line at the right, this line at the top, this line at the bottom. So the integral from a through b, upper minus lower, and that is going to give me my area. So it's not really very complex concept. It's the same as in the middle school. Okay, So let me just show you here something. The notes. Yes, you have here this one. So in this case, you again have this one is the same reasoning. In this slide, you can see the same. You have two functions that are continuous on an interval, a, b. Then one function is above the other one. So one is the upper, the other one is the lower. And then you want to find the area of the region bounded by the graphs f and g, and the vertical lines x equals a, x equals b. So the area is the integral from a to b of the upper function minus the lower function. The reasoning is very simple. So is what you see here. So you see the two, right? And when you subtract, you get the area between them, correct? So it's the same concept. So let's do one example here. For instance, this problem. Yeah. In this situation, this is okay. I have the function y equals a square root of x, y equals x squared. Now, these are the functions you have. And here the situation is you don't have an interval, but this function intersections. So we have to find the intersections. So remember the diagram. So this is a square root of x, more or less like this. This is x squared. So both intersect. So you want the function between the intersections. So you want the area between the intersections. So obviously you have one intersection point here, one intersection point here, and that's possibly the algebra you have to do. It's okay. So find intersections means you have to find where these functions are equal. So y equals, in this point the y's are equal, in this point the y's are equal. So is the square root of x equals x squared, correct? Then this is okay. Let me just square this thing. So you have x equals x to the fourth, correct? You square. We are going to do some algebra here. And then, well, what you are going to do is this. You are going to move everything to one side. So you have x to the 4 minus x equals 0. Then you factor an x cubed minus 1 equals 0. And then you remember the algebra. If a product is 0, then one of them has to be 0. This is 0 or this is 0. So you got to split this in two. This is already done. So the first intersection happens at x equals 0. And this is x equals 1 because the cubic root of 1 is 1. So the functions intersect in x equals 0 and x equals 1. So you have 0, 1. So this is A and this is B, correct? Now my calculus, not a big deal. My formula says, okay, the area between the curves is the integral from A through B, upper function minus lower function, right? Yeah. And here it's not difficult to know who's the upper function. So here, this is the square root, and this is x squared. So between 0 and 1, the square root is above the x squared. After the 1, they flip, but we're interested in the region between the intersections. So not a big deal. So here is going to be the integral from 0 through 1, parentheses, the square root of x minus x squared dx. Okay, once you have this formula, you have to use your formulas from your formula booklet. So you have to pretty much know that these are two powers. So it's the integral 0 to 1 x to the 1/2 dx minus the integral 0 to 1 x squared dx. So that's my algebra, right? And then you use the power rule to do this one. So this is x 1/2 plus 1 over 1/2 plus 1 evaluated from 0 to 1, right? And this is the integral x cubed over 3 from 0 to 1. Then this is 3/2, this is 3/2. So you have here 2/3 x to the 3/2 0, 1 minus 1/3. Is going to be here 1/3 x cubed evaluated in 1 minus x cubed evaluated in 0. Yeah, and then only you have to get 1/3 here minus 1/3. Here is 2/3 times 1, 2/3 times 0, so 2/3. And then you know that 2/3 minus 3/3 is 1/3. So this is the area between these two curves. So again, you want to find the intersection, well, you want to find the area between these two curves. They intersect, okay. So you are going to find the area of this oval right here. So the first thing you need to know is where they intersect, the x's for those intersections. So you have to do algebra, so they are equal when the y's are equal. Then you make these two equals. Then you solve the equation algebraically, and then you find 0 and 1. Once you have this is 0 and this is 1, you use your calculus formula. Integral from a to b, the difference of the functions upper minus lower. In this case, not difficult to see that the upper is the square root, the lower is the x squared. Yeah. And you put these formulas here, and well, the rest is only the solution of the thing. Now, I'm trusting really that you know how to do these integrals, because with the calculator, let me just show you, right here. Let me just use a new one right here, new document, save, and you press the calculator. So you can simply take menu, calculus, integral, and then you have here 0 through 1, right? And then here you have parentheses, and then you have to remember who's the upper, so it's control square root of x, right? Minus x squared dx. So with the calculator, it's pretty easy. And you press enter, and then you get 1/3. This is the same answer. So my expectation is you know how to solve these integrals by hand, okay, but you can use the calculator to verify that your answer is correct, okay? Then also you can possibly use the calculator for graphing. So my assumption also is that you're able to graph these functions without a calculator, and you can determine which one is the upper, which one is the lower, correct? So, any question till this point? So the concept is not very difficult. It's pretty much simple. You require your algebra, if you have to find intersections, and then you require your calculus to evaluate an integral. Okay, let me see now this one. Let me see if I have something here more interesting. For instance, this one, right? Here you have this one right here. Now let's do a trigonometric equation. So you have this, find the area between the two given curves. One is cosine x and the other one is sine x, okay? And then you want to know the area between x equals 0 and x equals pi over 2. Well, this is the graph. I'm not going to suffer graphing. Red line is cosine between 0 and 2 pi. Blue line is sine between 0 and 2 pi. Now you see they intersect, but they flip. Before pi over 4, cosine is above the sine. And after pi over 4, sine is above cosine. So in the whole 0 pi over 2 interval, these functions flip. At the beginning, one is the upper, and at the end, the other one is the upper. So in this case, what you have to do, this is very simple. Let me just write these expressions in the board, right? And solve the problem. So I have y equals cosine x, y equals sine x, right? The x equals 0, pi over 2, right? Or the interval 0, pi over 2. Yep. So let me just go back to my board. Here is my board. So we have y equals cosine x, y equals sine x. The interval is 0, pi over 2. And as we saw in our drawing, sine is something like this, and cosine is something like this, correct? So this is the intersection pi over 2. So we need this area, and we need this area. So they cross and they switch. Let me just do this a little bit better. Yeah, like this. Yeah, something like that. Okay. So the first thing I have to do is find intersection. Intersection. So where are the intersections? It's very simple. When the two y's are equal, remember the intersection happens when the y is equal. So you have sine x equals cosine x. Now, in the interval 0 pi over 2, where the sine is more than the equal than the cosine, well, if you remember, yeah, and your I don't have it here to show you, but if you see your formula booklet, you are going to find that this is going to be, yeah, pi over 4, correct? So this is pi over 4. Pi over 4. Okay, now, so from 0 to pi over 4, yeah, the area is going to be the integral. Now, from pi over 4, the upper function is cosine, and the lower function is sine. So you have to take the integral like this. After pi over 4, between pi over 4 and pi over 2, right? The upper function is the sine, and the lower function is the cosine. So again, upper minus lower, dx. So your problem is going to be really a couple of integrals from this section and this section. Upper minus lower, when you switch, you cut your integral here, pi over 4, and then from pi over 4 to pi over 2, then you have upper minus lower again. Now, it's very simple. So if you remember, the antiderivative of cosine is negative sine from 0 pi over 4, minus the antiderivative of sine is the cosine, x 0 pi over 4. Use only the signs, right? Plus antiderivative of sine is going to be negative cosine x from pi over 4 to pi over 2, and sine x pi over 4, pi over 2. Obviously, I have to put here pi over 4. This is a square root of 2 over 2 minus sine of 0, and so on. And then I'm going to get here an answer. I am assuming that you know this, so let me just go to the calculator to show you how to do this. Remember, if you don't want to type too much, you have to do define, yeah, define space f of x, right? F of x equal sign, equal sign. Let me just put here sine x. Enter. And then, let me just take this out. Yeah, you copy, paste, and then you can put here g, and here the cosine. Cosine, press enter, you define the two. And then the only you have to do is do the integral. So menu, calculus, integral. So 0, control no, is pi over 4, right? And here, parentheses, f parentheses x minus, yeah, g parentheses x. No, is cosine over sine is g over f. Yeah, minus f. So because the cosine is above the sine, so here I put the x, here the x, oh, here the x, right? And then plus, again, the integral, okay, menu, calculus, integral. Then you are going to put here pi over 4, right? Over 4 divided by 4. Yeah. Here, pi over 2 divided by 2. And then here, parentheses, f minus g. Okay, there is. Now, you press enter, and you get your answer. The square root of 2 over 2, square root of 2 minus 2. So this is exactly what you get. You could get if you go back and evaluate these things right here. It's the same answer. So this is the square root of 2 over 2. This is square root of 2 over 2. This is square root of 2 over 2 minus 0, and so on. Okay. So is your answer to a square root of 2 minus 2. Okay. Everybody fine with this? It's very simple, not difficult. So now let's go to the assignment. The assignment we have here is pretty much the same, right? So I'm going to do just a couple of these ones. So don't worry about the integration. If you have the calculator, right, you can use the calculator to do the integrals, correct? So let me just do one more. So I have here the area between 3x squared, y equals 3x squared minus 12, y equals 3x plus 6, right? Okay. So this is what we have to solve now. And again, what is the procedure? This is because there are no points, x equals something, you have to find the intersections. So what you have to do, well, 3x squared minus 12 equals 3x plus 6, right? And then you do the algebra to solve this one. This is 3x squared minus 3x minus 12 minus 6 equals 0. Okay, this is 3x squared minus 3x minus 18. You divide everything by 3, is x squared minus x minus 6. And then you solve this quadratic. Two numbers you multiply, you get negative 6, and you add, you get negative 1. So this is x minus 3, x minus plus 2 equals 0. 3 times 2, negative 6, negative 3 plus 2, negative 1. And then you find the intersections, x equals 3, x equals 2, correct? Okay, now what? Well, this is going to be your A, this is going to be your B, right? And the only thing you have to find is who's the upper function. So, okay, between 2 and 3. What do you think is going to be the upper? Well, let's suppose 1.5, 2.5. So 3 times 2.5 is 7.5. This is 13. And 2.5 squared is less than 3. Yeah. So this is going to be a negative, right? So you don't have to do the things. So this is a positive, this is a negative. So this is the upper, this is the lower. So what you are going to do is, okay, my calculus says the area between the regions is the integral a, b, f of x minus g of x, the x. So in this case, the f is going to be this one, the g is going to be this one, right? And well, a is 2, b is 3, so what we only have to do is integral from 2 to 3 of, I'm going to write it, so it's 3x plus 6 minus 3x squared plus 12. Okay, be careful, this minus is going to change this and this. That's why I have minus and plus. Then, well, you can do this by hand, or you can go to your calculator, right? Yep, this one. So we have, okay, menu, calculus, integral. So is the integral from, let me just put here, as 2 to 3, yeah. Here parentheses is going to be 3x minus 6 minus 3x squared minus, no, plus 12. Plus 12. Oh. Plus 12. Okay, and then put the x, representer, and then you have negative 11 over 2. This is negative 5.5. Okay, so this is my answer. Okay, so as I told you, I am assuming you know how to solve this by hand. So, well, I'm not going to make you do this by hand because I am assuming you know it. So you are free to use your calculator to get the answer. Obviously, I'm expecting to see in your assignment this work, right? And then the answer. Okay. Let me just do one more example, right? Let me see this one. Yeah, this one is good. So some problems are going to have the regions rotated, like in this case, you see, this red parabola is not a function. This parabola is x equals 1/2 y squared minus 3. And then this line, well, this line is explicit in x. X equals a function of y. So this is not really like these ones we solve here, that y is a function of x. Here, x is a function of y. So what you have to do in that case is, well, the first thing you possibly may do or try is try to y equals, but I don't think you have to do the thing. So let me just sketch right here in my board pretty much what we have here. Something like this. Okay, so this is y equals 1, no, x equals 1/2 y squared minus 3, and then x equals y plus 1. Okay, so let me just stop here, right? This one. Okay, so again, what you have to do is find the intersections, correct? Yeah. Okay. You can find the intersections, so this is okay. Let me see. The intersection, this is x, this is y. So what I'm going to do is pretty much make these two equals. Algebra 1. 1/2 y squared minus 3 equals y plus 1. And then I have another quadratic. I have 1/2 y squared minus y minus 3 minus 1 equals 0. So I put everything in one side. And then I multiply times 2. So I have y squared minus 2y. And this is minus 8 equals 0. Correct? Now, this is going to be y minus 4, y plus 2. That's my factoring. And then this is y equals 4 and y equals negative 2. Okay, this is the situation. You are running in y. So this is y, this is x. So what you are going to do is very simple. you are going to take this and you are going to rotate like this one. So you are going to make a mental rotation such that you have this in this way. So this is the y, this is the x, this is 4, this is -2. So what you are going to do is simply you are going to change the variables in your formula. So the area is the integral from a through b f of y minus g of y dy. So the variable is not important here in the integration, correct? Let me just do a better formula. So it's area is integral from a through b f of y minus g of y dy. And the only you have to do is, okay, who's my f of y? This is okay. F of y is the upper function, is the line. G of y is the lower function, is the parabola. So the only you have to do is a equals the integral from -2 to 4, parentheses, y plus 1 minus 1/2 y squared minus 3 dy. So you see, you repeat the same reasoning with a different variable. And again, we go to the calculator. The only thing is, in the calculator, you have to use x, not y. Okie dokie. So in this case, you have menu, calculus, integral. Then you're going to put here -2. You put here a 4, parentheses, and then you're going to put x minus 1, x plus 1, minus 1/2 x plus 3. Yep, plus 3, 3, 3. No, y is, this is x squared. This is x squared. And then plus 3. And then the x. And no matter what variables you have in your paper, in the calculator, you have to use the x. So press enter. That's my answer. It's going to be 18. Correct? So in my paper, I just put 18. Correct? So again, summarizing. If you have x as a function of y, so you have horizontal functions like this one, right? That are not functions really. So what you have to do is you proceed the same. You find the intersects. So in this case, you make the y's equal, you solve for y, right? Once you find -2, +4, right here, then you mentally flip this, and then you're going to integrate from -2 to +4. Now, the one at the right is the one at the top, and the one at the left is the one at the bottom. Then you repeat your formula, upper minus lower, no matter the variable. Then you plug in your functions with the limits. You can do this by hand, or you using the calculator, you get your answer. So this area is 18. Okay, questions? No questions? Pretty clear? Yep.